Plus India's first animated live tuition. So how are you guys doing? എന്താണ് ഓണൊക്കെ അടിച്ചു പൊളിച്ചോ? How was your Onam, guys? Did you enjoy your vacation? So do we have the comments? Yes. It was fine. It was adipoli. All right. Perfect. So അടിച്ചു പൊളിച്ച് നമ്മുടെ ചാപ്റ്റർ ഒക്കെ മറന്നുപോയോ? എല്ലാവരും പൊളിച്ചോ? Yes. Perfect. So everyone quickly turn on your cameras and show me your smiling cute little faces. Oh, you saw my dance. All right. Okay. Yes, my Onam was perfect, guys. It was perfect. Yes. So today, guys, we are going live. So a big hi to the YouTube family as well. All right. Yes. Perfect. So the chapter that we were discussing was metals and non-metals. Ale? Yes. And in the last class, we extracted metals with very low reactivity. My thumbnail is good, right? Yeah, perfect. Yes. Yes, we extracted metals with lower reactivity. Yes, now Jiki sir, he's sharing the links of the YouTube class, okay? So you can please share it with your friends, all right? Yes, perfect. In the last class, we extracted metals with lower reactivity. Okay, so in this class, we'll extract metals which has got medium reactivity. Then we'll see about high reactive metals. Engine high reactive aayittulla metals ine nammal extract cheyidedukunnathu. Okay, yes. Then we'll refine these metals. Refine means purification. Metals varde kittiya porallo. It should be pure, right? Yes, and we'll see how we can refine these metals. And our last topic is corrosion. Okay. Yes, so shall we start? If you're ready, you can give me some fire emojis. Fire ittu namukku start cheyam. Give me some fire emojis in the comment box and I'll start. Okay, perfect. So, yes, thank you guys. So the first one, yes, extraction of metals with medium reactivity. Now, give me some examples. No, today you will not have chapter test, okay? Yes. Now, give me some examples for metals with medium reactivity. Medium reactivity കാണിക്കുന്ന metals നെ കുറച്ച് examples പറഞ്ഞേ മിസ്സിനെ. Come on, quickly. We have zinc. Very good. We have zinc. We have iron. Yes, lot of metals. Okay. Now, the problem is these metals usually exist as their sulfides or carbonates. Okay. Appo medium reactive aayittulla metals, okay, they exist either as their sulfides or carbonates. Now, the problem is it is quite difficult to extract metal from sulfides and carbonates. Okay. Carbonates innum sulfides innum metal extract cheyyunnu parayunnathu korchu task aanu. So what we are going to do is we'll first convert them into their oxides. Okay, oxides il namukku easy aayittu endu cheyam metal ne extract cheyidedukka. Okay, so our first task is to convert these sulfides and carbonates into what? Into oxides. Now let's take zinc for example. Okay, now zinc in the sulfide ore aanu zinc blend. Okay, now the sulfide ore of zinc is known as zinc blend and the carbonate ore of zinc is calamine. Okay, which has got the formula ZnCO3. Okay, now what is the first duty? Our first duty is to convert these into their respective oxides. Now we have already discussed this process in our previous class. എങ്ങനെ നമ്മൾ സൾഫൈഡ് ഓർസിനെയും കാർബണേറ്റ് ഓർസിനെയും ഓക്സൈഡ് ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്നത്? How will we convert it? Do you remember? First, let's take the example of sulfide ores. First, നമുക്ക് സൾഫൈഡ് ഓർസിനെ oxide ആയിട്ട് convert ചെയ്യാം. Very good. We'll conduct a process called roasting. Okay. In the roasting, the sulfide ore, it is heated in presence of excess air. Okay, we sulfide ore heat in the presence of excess air. So what happens? The sulfide ore gets converted into its oxide. Okay, it gets converted into its oxide. Now, what was the sulfide ore of zinc? It was ZnS, right? Now, when zinc sulfide is heated in presence, you don't have to write it down, okay? I'll give you the notes, don't write it down now. Yes, when it is heated in the presence of excess air, what happens? It gets converted into its oxide. Okay, along with that, sulfur dioxide gas is also formed as a byproduct. Okay, now is this reaction balanced? No, we have to balance it. Okay, now the reaction is balanced. So sulfide ores oxide convert we conduct roasting. Now, what about carbonate ore? Now, what is the process of converting the carbonate ore into its oxide called? Very good. It is nothing but calcination. Appo namukku zinc inde carbonate ore ne calcination nadathiyalo? Yes. What is calcination? Here, the carbonate ore is heated in limited supply of air. Okay, nammal limited supply of air when we heat the carbonate ore, we get what? We get its oxide, and along with that, carbon dioxide gas is released. Okay, appo first nammal endu cheyidu? Nammade sulfides ineym carbonates ineym we have successfully converted them into their oxides. So is it clear? Now you can write it down. Yes, sulfide ores nammal roast cheyum, roast cheyidittu it is getting converted into its respective oxide. Now what about carbonate ore? We'll conduct calcination in which the ore is heated in limited supply of air so that it gets converted into its oxide. Is it clear? Any doubts so far? Alright, okay. Now we got the oxide. But is this our final aim? Our ultimate aim is the oxide kittanano? No, right? We need the metal. This oxide is not enough for us. We need the metal. Now, how will I extract the metal from its oxide? Oxide is metal. That means I have to remove that oxygen. Now, what is that process called? What is removal of oxygen? Very good. I have to conduct what? I have to conduct reduction. Yes. Ini I engane reduce the metal oxide. This oxide is treated with a suitable reducing agent. Okay. And the most common reducing agent that we use is nothing but carbon in the form of coke. Okay. Yes. Now, the zinc oxide which is obtained is reduced into the metal by heating it with carbon. So, when I heat my zinc oxide with carbon, okay, I'm heating it in the presence of carbon, what happens is that zinc oxide gets reduced into the metal zinc, and along with that, carbon dioxide is also formed. Okay, so our carbon here act as the reducing agent, okay, and it will reduce zinc oxide into the metal zinc. So is the reduction clear for you guys? Is the reduction clear? Yes. So from the sulfides and the respective carbonates, I got my metal zinc. This is how you extract metals with medium reactivity. What is roasting and calcination? We've already discussed. Roasting is nothing but heating the ores in the presence of excess amount of air. Excess amount of air heating. Now, the metal, when it is heated in limited supply of air, it is called as calcination. Okay, it is calcination. Yes. All right. Yes, hi Naveen. Yes, a hi, big hi. All right, yes. Now it's not that we can only use carbon as a reducing agent. Carbon മാത്രമല്ല നമ്മൾ use ചെയ്യുന്ന reducing agent. We can use metals with high reactivity, just like sodium, aluminum, calcium. ഇവരൊക്കെ എന്താ ഇവർക്കൊക്കെ they are highly reactive metals. Okay, so ഈ metals നെ ആയിട്ട് treat ചെയ്തിട്ട് നമുക്ക് we can conduct a displacement reaction. Okay, then also we can easily extract the metals from their compounds. For example, MnO2, it is nothing but pyrrolosite, right? When manganese dioxide is treated with aluminium powder. Okay, when it is treated with aluminium powder, what happens is that since aluminium is highly reactive, it will displace manganese from its oxide. Okay, so aluminium MnO2 reduce ചെയ്തിട്ട് we'll get manganese. Okay, yes, what happens is that aluminium will displace manganese from its oxide and it will form the oxide of aluminium. This is the reaction taking place. This is the displacement reaction that is happening here. Is it clear? Yes, now the equation is balanced. Okay, what did I say? You can use highly reactive metals as reducing agents in order to extract metals from their oxides. Okay, why? Because they are highly reactive. It will easily displace the lower, yes, metals with lower reactivity. I'll explain it again. Yes, carbon മാത്രമല്ല നമ്മൾ എപ്പോഴും യൂസ് ചെയ്യുന്ന reducing agent. You can use metals which has got high reactivity as reducing agents as well. For example, we can use sodium, we can use aluminum, we can use calcium. Okay, since they are highly reactive metals, lower reactive metals they will easily displace from its oxide. Okay, our oxide metals displace reduce pure metal. Okay, it's not pure, we have to purify it, but still we get the metal. Okay. Thank you, Abhinand. Thank you so much. Okay. Yes. So, these displacement reaction using highly reactive metals, it is actually a highly exothermic reaction. Okay. What huge amount of heat is released during this process. Okay. It is so hot that the metal obtained here is in its molten state. Okay, then this highly molten liquid formula metal. This reaction is highly exothermic. Exothermic means a lot of heat is released during this process. Okay, so heat release the metal which is obtained here is in its molten state. Liquid formula namukku kitta. Okay, is it clear? Yes, you can write it down. These displacement reactions are what? They are highly exothermic. Okay, it is so exothermic that the metal obtained here is in its molten form. Okay, it is in molten state. And this reaction has got some application as well. Okay, these displacement reactions exothermic it has some. Yes, you can write this slide, I will show you. Yeah, you can take this down. First, you can take a quick screenshot and then start writing, okay? Alright, yes, and still slides are last no worries, okay, yes. Yes, so one such application is Thermit reaction. Oh, sorry. Thermit reaction. Now, what is Thermit reaction? It is the reaction between ferric oxide. What is ferric oxide? Ferric oxide is Fe2O3. Okay. Ferric oxide is treated with aluminium. Okay. Ferric oxide na nammal aluminium treat cheyan. Now, since aluminium is highly reactive than iron, aluminium will displace iron. Okay. Aluminium iron in a displace we'll get what? Fe2O3 get reduced into Fe, and along with that we get the oxide of aluminium. This is the reaction taking place, and it is highly exothermic. It is highly exothermic. Yes, it's the same thing, Nevin. It's the same thing. Yes. Now, Thermit reaction is, this reaction is called Thermit reaction, and it finds its application in what? In joining railway tracks. Okay. Adepole cracked machine parts adokka join cheyan vendite we use this reaction. This thermit process aanu nammal avade nadathunathu. Alright. Yes. It is a reaction between ferric oxide. Yes, ma'am, it's the same. Nevin is the same thing. Okay. Yes. Yes. The reaction between ferric oxide and aluminium is known as thermit reaction. Alright. Yes, and since this process is highly exothermic, what happens is that it is used to join the railway tracks and also to join cracked machine parts. Now, this is an important point. You can give some star. They used to ask this question. What is thermit reaction? Or like explain thermit reaction and give its applications. They used to ask the question. Okay. Now, this is important. You can give a star. Alright. Yes, parayalo. Iron oxide, that is ferric oxide, is treated with aluminium. Okay, so what happens? Since aluminium is more reactive, okay, since aluminium is more reactive than iron, aluminium poite iron ne displace. Okay, aluminium will displace iron from its oxide. എന്നിട്ട് നമുക്ക് iron കിട്ടും അതേപോലെ തന്നെ aluminium oxide കിട്ടും. Now in this process a large amount of heat is released. Okay, large amount of heat release ആയതുകൊണ്ട് തന്നെ the iron formed here will be in molten state. Okay, iron ഇവിടെ molten state ൽ നമുക്ക് കിട്ടുന്നത്. And this is used to, this reaction is used to join the railway tracks and also to join the cracked machine parts. Okay, this is the thermit reaction. Simple reaction. Now, can I ask you a question? In this thermit reaction, can you identify the substance that is getting oxidized and the substance that is getting reduced? The substance which is getting, which is the, or, yes, very good. Chodikkinenu munne answer vannu. Aluminium is oxidized to Al2O3. That means aluminium acts as the reducing agent, right? Yes, and Fe2O3 is reduced to what? To Fe. Very good, very good. Yes. So shall we move on? Is the slide done? Yes. Okay. Alright. Now the next section. Now we are going to extract the metals which has got very high reactivity. Now quickly give me some examples for metals with high reactivity. Edake example? We have sodium, we have calcium, yes, potassium, lot of metals. Aluminium, yes, perfect. Now, medium reactivity metals in extract first we'll convert them into their oxides and then we'll use a suitable reducing agent to reduce it into the metal. Our task ivada nadakula. Okay, why? We cannot use reducing agents like carbon to extract metals like sodium, potassium or aluminium from their oxides. Why? Because this sodium, magnesium, like aluminium, okay, they have got higher affinity for oxygen. That is, carbon oxygen or affinity these metals has got a strong bond between them and the oxygen. So it is not possible to break that bond using carbon. Okay, so here we are using a totally different process. Okay, a totally different process are using and it is called electrolytic reduction. Okay, we are passing electricity. Okay, electrolysis nadathitana nammal metals ine extract cheyyunnathu. Okay, now the metals with higher reactivity is obtained by conducting what? Conducting electrolytic reduction. Okay, now these metals usually exist. Free state why? Because they're highly reactive. Free state exist. Okay, and they commonly exist as their chlorides, and some of them exist as their oxides as well. Okay, chlorides are majority in the so what we'll do is we'll take the chloride and we'll melt it. Molten chloride okay, molten chloride a molten chloride electrolysis okay. So the metals like sodium, magnesium, calcium are obtained by the electrolysis of its molten chloride. Yes, molten means it is melted. Liquid form il nammal melt cheyanam. Okay. Yes. Yes, the same thing only. Shivapriya, same thing only. Okay. Electrolytic decomposition means that is we are passing the electricity through a metal so that it gets splitted into simpler products. So that is electrolytic decomposition. Okay. Yes. Now, sodium, magnesium, aluminium, they are all like we'll take the molten chloride form and we'll pass electricity. Now, when we pass electricity, what happens is that the metals, okay, get deposited at the cathode. Now, that is an important point. Okay, the metals gets deposited at the cathode, and at the anode, what happens is that chlorine gas will be liberated. Okay, when we conduct the electrolysis of molten chloride, what happens is that the metals get deposited at the cathode. This is an important point, guys. They directly ask this question. Okay, during the electrolytic refining, where can you find or where the metals get deposited? It gets deposited at the cathode. Now, anode, since we are taking the chloride, chlorine gas is liberated at the anode. Okay, now, shall we conduct electrolytic refining of sodium chloride? Okay, sodium extract. Yes, sir. Can we have our animation? Yes. Alright, so here I have taken in a beaker some molten sodium chloride. Okay, sodium chloride, what are the ions present there? I have Na plus ions and Cl minus ions. Yes, sir. Let's pass some electricity. Yes, wait, sir, wait. Alright, now you can see there is a positive terminal and a negative terminal. The electrode connected to the negative terminal of the battery is called the answers. Okay. Two answers miss. Okay, alright. Now, the electrode connected to the negative terminal is called the cathode. Okay. It is cathode. And the one connected to the positive terminal of the battery is anode. Okay. So, you are done with cathode and anode. And let me ask you a question. You might have studied in your lower classes that like charges will repel and unlike charges will attract, right? Yes, similarly, yes, very good, yes. I have got some positive ions as well and some negative ions, right? Now, yes, panic. Diya, you remember that? Yes, alright. Okay, so Na plus, since it has got positive charge, what happens? It will migrate into the negatively charged cathode. Yes, sir. You can play the animation. See? What just happened? When I passed electricity, Na plus ions migrated to the negatively charged cathode and the Cl minus ions migrated towards the positively charged anode. Okay? And what actually happened here is, see, I'll write it. Yes. No need to. Yes. At cathode. what happened is that my Na plus ions, okay, Na plus ions, they migrated towards the cathode, and at the cathode, what they did was they accepted one electron. Or electron ne avare accept chedu. Okay, they accept. So can I use the pen? Yes. They accepted an electron and they got converted into Na. Sodium metal I. Okay, Na plus. In the Na plus ion, it accepted an electron and it got converted into Na. Now tell me guys, what is gaining of electron called? The process of gaining of electron is known as? Gaining of electron, it is nothing but reduction. Okay, that is nothing but reduction. Gaining of electron is reduction. So I can say that at cathode, what will happen? At cathode, reduction happens. Okay. Na plus is reduced to Na. Okay. But cathode reduction. Now what happens at anode? You can see the chlorine gas is getting liberated at anode. Now anode reaction yes. At anode, what happens is that the chlorine, the Cl minus is anode like migrate Cl minus Cl minus electron, it will lose. Okay, it will lose its electron and it gets converted into chlorine gas. Cl2 gas out. Along with that, electron is liberated. Now we have to balance this. In the right hand side, you can see there are 2 chlorine atoms. But in left hand side, there is only 1 chlorine atom. So we'll balance it. And we should also balance the charge. So this will be the balanced equation for the anode. Okay. Up anode the Cl minus ion, it will lose its electron and it gets converted into chlorine gas. Now tell me, what is loss of electron called? The process of losing of electron, it is nothing but oxidation. Okay, it is nothing but oxidation. So guys, yes sir. Chloralkali process brine solution electrolysis alle. Okay, that is different. Okay, yes, sure, Priya. Yes. Okay, yes. Now, at cathode, what happens? Yeah, chloralkali process is sodium hydroxide alle, like formation alle, like brine solution that is NaCl mixed with water. Here it is molten NaCl. Okay, that is the difference. Molten NaCl. Alright. Yes. So always remember that at cathode reduction happens and at anode oxidation happens. Now, how will you remember it? Cathode oxidation, cathode reduction anode oxidation how will you remember it? It is also, reduction is nothing but, yeah. Okay, we reduction examples like definition it is gaining of electron or removal of oxygen or gain of hydrogen. This is reduction, okay? Yes. So you can remember like this. Anox, red cat. This is anox, red cat. That is anode oxidation and reduction at cathode. So that you will never forget. Okay, anox, red cat. Alright. So is it clear? So is the electrolysis clear? Now the question, one word question you can expect is, where is the metal getting deposited? Is it at the cathode or is it at the anode? It's at the cathode. Don't forget that. Okay. Yes. Is it clear? Alright. Yes, sir. You can remove the animation. Okay. Perfect. And you can write down this reaction as well. Yes. Done. Can I change the slide guys? Okay, I'm changing it, okay? Yes. Now our final step is we have successfully extracted the metals. Okay, we metals extract eduthu. Now our task is to purify these metals. Okay, we metals these metals are not completely like 100% pure alla. We need to purify these metals. These metals purify the process is nothing but refining of metals. Okay, and what is the most common method of refining metals? It is electrolytic refining. Yes, the metals will be contaminated. We need to remove the impurities in order to get obtain the metals with high purity. Okay, and the most common method that we use is nothing but electrolytic refining. Okay, we conduct the electrolytic refining of copper, nickel, tin in order to get highly purified metal. Okay, now let's see in detail the electrolytic refining of copper, and this is a very important topic, guys. You can give as many stars as you want. Okay, so shall we do the experiment? Okay. Oh, thank you, Yashodev. Thank you so much. Yes, Binda slides of last don't worry. Yes. Last of Miss Ondugoda Paranuru. Abhinan, don't worry. I'll explain it again. Okay? Yes. Alright. So here I have my experimental setup, guys. Now quickly tell me, the electrode that is connected to the positive terminal will be what? The electrode that, very good, it is the anode. So I have my anode here, and here I have my cathode. Okay, now listen carefully, guys, this is so important. My impure metal, okay, the impure metal is always taken as the anode. The anode is always the impure metal, and a thin strip, okay, a thin strip of pure metal is taken as the cathode. Is it clear? Impure metal ne jana anode aaki eduthu, adepole a thin strip of pure metal is taken as the cathode. Now, the metal aano ullathu, metal le thanne salt solution aanu njan ende electrolyte aayittu edukkunnathu. So what is electrolyte here? The metal salt. Okay, metal salt ne nammal edu metal aano vendathu, metal thanne salt solution aanu ende electrolyte. Since we are conducting the electrolytic refining of copper, I am taking impure copper as the anode. Okay. Yes, same ആണ്. Pure impure pure same metal തന്നെയാണ്. Both is copper. Okay. One is impure, one is pure. Okay, yes. So my anode is impure copper and my cathode is pure copper. Okay, ഇവിടെ pure copper ആണ്. ഇവിടെ കുറേ impurities and contaminants ഉണ്ട്. Now, salt solution I have taken is that of copper sulfate. Okay, ഏത് മെറ്റലിലാണോ ഇലക്ട്രോൺ ഉള്ളത് ആ മെറ്റലിൽ തന്നെ salt solution വേണം. So I have taken copper sulfate. Okay, ഇതാണ് നമ്മുടെ experimental setup. Now we are going to pass electricity. Yes, sir. And let's see what happens. Yes. Yes, sir, you can pause it. Now, whenever I start passing electricity, what happens is that the pure metal from the anode. Anode is pure metal. Copper undu adinte kuda korchu impurities undu. Alle? The pure metal from the anode will get dissolved into the electrolyte. Yes, sir, you can play it. Okay. Appo pure metal anode il ninnu endu cheyum korchu dissolve aayittu nammade electrolyte solution like vannu veerum. Now, an equivalent amount of CO2 plus from the electrolyte gets deposited at the cathode. എന്താ ഇപ്പോൾ സംഭവിച്ചേ? ആനോഡിൽ നിന്ന് പ്യുവർ ആയിട്ടുള്ള copper, it gets dissolved into the solution. എത്ര amount copper solution dissolve ആയോ അത്ര തന്നെ copper it gets deposited to the cathode. സൊല്യൂഷനിൽ നിന്ന് കാഥോഡിലേക്ക് copper ആയിട്ട് deposit ആവും. Is it clear or is it confusing? Should I explain it again? I'll explain it again. Okay. Yes. Whenever you pass electricity, what happens is that my anode is nothing but impure copper. Adile copper undu, some impurities undu. The copper gets dissolved into the electrolyte solution. Ee electrolyte like korchu copper anode il ninnu dissolve avum. Etra amount copper dissolve ayo atrayum thanne copper solution il ninnu cathode il poite deposit avum. Okay. Cathode il poite deposit avum. Simple. Anode il ninnu solution like dissolve avunu. എത്ര എണ്ണം സൊല്യൂഷൻ ഡിസോൾവ് ആയോ അത്രയും തന്നെ സൊല്യൂഷനിൽ നിന്ന് തിരിച്ച് കാഥോഡിലേക്ക് പോകുന്നു. സിമ്പിൾ. ഇത്രയേ ഉള്ളൂ. ഓക്കെ. Now, what happens is that, sir, can we play this animation again? Yeah. Now, as this process continues, you can observe that the anode will become thinner and thinner. Anode ingane thinnayi vanondirikkaanu. Right? But what about the cathode? It is getting thicker and thicker. Okay, anode la pure copper vannittu deposit cheyidittu it is getting thicker and thicker. Now, the insoluble impurities. We have lot of impurities present here. Adile korchu impurities okke soluble aanu and some of them are insoluble. Okay. Now, the soluble impurities will get dissolved in the electrolyte. This solution will dissolve out. Now, there are some insoluble impurities present. Insoluble impurities, okay, they will settle at the bottom. Okay, just settle, they fall below what? The anode. Anode in the thare settle either kadukkum. The impurities which are not soluble. And this is called as anode mud. What we call this insoluble impurities as? Anode mud. Okay, this is called as anode mud. Now, what are the important points that you have to keep it in mind? The impure metal is taken as the anode. Okay, and a thin strip of pure metal is taken as the cathode. ഇനി ഏത് മെറ്റൽ ആണോ എനിക്ക് പ്യൂരിഫൈ ചെയ്യേണ്ടത് ആ മെറ്റലിന് തന്നെ സോൾട്ട് സൊല്യൂഷൻ ആയിരിക്കും എൻ്റെ ഇലക്ട്രോലൈറ്റ്. ഓക്കെ, ആൻഡ് വെൻ യു പാസ് ഇലക്ട്രിസിറ്റി വാട്ട് ഹാപ്പൻസ്? The metals, the pure metal from the anode gets dissolved into the solution. Solution dissolve out. ഇനി എത്ര amount metal dissolve ആയോ അത്ര amount solutionൽ നിന്ന് copper like cathode പോയിട്ട് deposit ചെയ്യും copper ആയിട്ട്. Okay, this is the reaction that is taking place here. And the soluble impurities will get dissolved in the solution. Solution dissolve ആയിട്ട് കിടക്കും. And we will have some insoluble impurities as well. Insoluble ആയിട്ടുള്ള impurities എന്ത് ചെയ്യും? They will get settled at the bottom. Just anode ന്റെ താഴെയായിട്ട് അവർ settle ചെയ്തിരിക്കും. Okay, and this is called as anode mud. നമ്മൾ എന്ത് പറയും? Anode mud. This is how we refine a metal. Now we will get metals with high purity. We will get metals with high purity. Is it clear? Because it's a reduction process. Reduction എവിടെയാണ് നടക്കുന്നത്? It is at cathode. Cathode ലാണ് like ions reduce ചെയ്തിട്ട് like copper എന്ത് ions form ചെയ്യുന്നത്? Cu2 plus ions. Cu2 plus ആയതുകൊണ്ട് അത് നെഗറ്റീവ് ഇലക്ട്രോഡിലേക്കല്ലേ പോകുന്നത്. Reduction happens at the negative electrode. അതുകൊണ്ടാണ് കാഥോഡിൽ പോയിട്ട് ഡെപ്പോസിറ്റ് ചെയ്യുന്നത്. Okay? Yes. Alright. Okay. So, you can remove the animation. Is it clear? Is it clear, guys? So, ഏതാണ് impure metal? എവിടെയാണ് നമ്മൾ impure metal വെക്കുന്നത്? എവിടെയാണ് pure metal വെക്കുന്നത്? It's a repeated question. They used to ask it. Alright. So, shall we see a quick summary on the extraction, like our metallurgic process mottham namukku kandalo. Yes, so you can yes, the banner is gone already. Yes, perfect. So here first namukku ore aayirunnu. Ore ne nammal endu cheyidu, just korchu impurities okke remove cheyidu. That process is known as the concentration of ore. Okay, it is called the concentration or enrichment of ore. Now from the concentrated ore we extracted what? Extracted the metals. Now since the metals can be divided into the metals with high reactivity, medium reactivity, low reactivity, extraction process is also different. Okay, so the metals with high reactivity, nammal engine extract cheythathu? We conducted electrolysis. Nammal electrolytic reduction aanu avade cheythathu. Okay, so on electrolysis we will get pure metal. Now what about the metals with medium reactivity? They are present as either, this is there in your textbook, you don't have to write it, okay? No need to write it. Yes, these metals are present as carbonates or sulfides. So the first task for us was to convert them into their oxides. Okay, oxides aayittu nammal convert cheyanam. Now the carbonate ore is converted into its oxide by a process called calcination, and the sulfide ore is converted into its oxide by a process called roasting. Okay, now the oxides so obtained is then treated with a suitable reducing agent. എന്നിട്ട് നമ്മൾ reduce ചെയ്തിട്ട് എന്ത് ചെയ്തു? നമുക്ക് മെറ്റലിനെ കിട്ടി, and we purified the metal. Now what about the metals with lower reactivity? Lower reactivity, we were simply heating it. We just roast it. We just heated it in presence of plenty of oxygen. So the metal got converted into its oxide first, and from that we got the metal. And after that we'll conduct refining of that metal. Idayirunnu the entire metallurgical process. Was it clear? Is it clear, guys? Okay, so അങ്ങനെയാണെങ്കിൽ നമുക്ക് നമ്മുടെ ഫൈനൽ ടോപ്പിക്കിലേക്ക് പോയാലോ? ഫൈനൽ ടോപ്പിക് ഇസ് നത്തിങ് ബട്ട് corrosion, which we have already seen in our first chapter. അല്ലേ? corrosion നമ്മൾ already പഠിച്ചതല്ലേ? So just tell me what corrosion is. മിസ്സിനെ പറഞ്ഞായോ നിങ്ങൾ? നോക്കട്ടെ. corrosion എന്ന് വെച്ചാൽ എന്താ? Ma'am, so is my voice clear? Yes, okay. Yes, perfect. corrosion. റസ്റ്റിംഗ് എന്ന് പറയുന്നുണ്ട്. ഓക്കെ, മണ്ണെണ്ണയോ? യെസ് യെസ് യെസ്. അപ്പൊ നിങ്ങൾക്ക് അറിയാം. സ്ലോ ഈറ്റിംഗ് അവേ, ഡീഗ്രഡേഷൻ ഓഫ് മെറ്റൽസ്, റസ്റ്റിംഗ് ഓഫ് അയൺസ്, or killing of a metal. Okay, so you know the thing. Corrosion is nothing but it's a slow process. Okay, it's a slow process in which the metals, it gets damaged. Okay, endonde damaged avunu? It is maybe due to the presence of air, moisture or other gases present in the atmosphere. It is a damaging process, and it is also really slow. It's a slow process. Okay, yes, this slow process of damaging metals is known as what? Corrosion. Okay, it is known as corrosion. Is it clear? Yeah, the degradation of metals. Yes, when exposed to moist air. Yes, that is nothing but corrosion. Okay, is it clear? So shall we do another experiment? Okay, I'll explain it again. Yes, the slow process. Okay, the slow process in which a metal gets damaged. Metal ingane damage aayi po, or you can say eating up of metals ennu anengil parayam. Okay, due to the presence of air, moisture, അല്ലെങ്കിൽ ബാക്കി other presence of some other gases in the atmosphere. ഇതിനെയാണ് നമ്മൾ എന്തെന്ന് പറയുന്നത്? corrosion എന്ന് പറയുന്നത്. Okay, damaging of metals. Metals will get damaged. ഇതിനെയാണ് നമ്മൾ corrosion എന്ന് പറയാം. Now let's see an experiment. So can we have our image? Yes, first നമ്മൾ rusting of iron, corrosion of iron ആണ് കാണുന്നത്. Now the process of corrosion of iron is known as rusting. Okay, അതിനെയാണ് നമ്മൾ rusting എന്ന് പറയുന്നത്. Yes, here I have 3 test tubes. Okay, you don't have to write it down, you can put down your pen. Yes, here I have got 3 test tubes here. First test tube, that is test tube A, I have filled 3/4 of it with water. 3 test tube iron nails aanu. Okay, yes. 3/4 of it I have filled it with water. Now in the second test tube, I have taken some distilled water. Okay, I have taken some distilled water, but here this water is boiled. Okay, why is it boiled? Karanam, water will contain some dissolved gases in it. Okay, adokka remove idu kalayan vendite I have boiled it. Now, adinte top I have added a layer of oil. That is to prevent the contact with air. Air water will dissolve avadirikan venditana. Okay. Now, in the third test tube, I have taken some calcium, anhydrous calcium chloride. This calcium chloride, it is a drying agent. That is, it will absorb the moisture. Moisture content absorb it. So that in the third test tube, there is only dry air. There is no moisture content present in the third test tube. Okay, first test tube, I have water and air. In the second test tube, there is the nails, iron nails are only exposed to water. Water matre ullu avade. What about the third test tube? Third test tube, there is only dry air, there is no moisture. And when you take a closer look, test tube A iron nails matramana rust cheythu. Only the first test, iron nails in the first test tube got corroded. Now, what can you conclude? What can you conclude from that? Yes, so the necessary condition for rusting of iron is that there must be the presence of both air, that means oxygen, and water. Both oxygen and water indengil matre indeyullu. If there is presence of air and oxygen, like water only, the iron articles will corrode. Okay, is it clear? Or should I explain it again? Rusting of iron, both we need air and water. The presence of air and water is necessary. Second, look, first test tube, I have water and air. Water and air presence, my iron nail got corroded. But what about the test tube B? In the test tube B, it is only exposed to water. Water matre ullu. There is no air here. Okay, adonde second test tube iron endidilla rust cheyidilla. Now, third test tube anengilo, there is no moisture content here. There is only dry air. Appo endidilla third test tube iron nails corrode cheyidilla. There was no corrosion here. First test tube iron nail matre corrode cheyidullu. So from that I can say that for the rusting of iron, it requires both air and water. And now matre iron articles they will corrode. So you can remove the image. Yes. Okay, so this is the reaction that is taking place here. For the iron objects to corrode, it requires the presence of both oxygen and water. Then only it will undergo corrosion. Now, what is rust? Rust is nothing but hydrated what? Hydrated ferric oxide. Hydrated ferric oxide is rust. So, iron will react with oxygen and water to form hydrated ferric oxide, which is known as rust. Can you see this? Yeah. Which is known as rust. X is a number. It can be any number of water molecules. Okay. So, we will write it X. X is the represent here. X H2O. X can be any number. There is no fixed amount. Okay. Yes, that's why we represent it as Fe2O3 dot X H2O. Okay. Alright. Now that is rusting of iron. Now, you might have seen this. You might have seen this. What is this? This is tarnishing of silver. Okay, the silver utensils and all gets tarnished or it gets blackened when exposed. When exposed to air. Okay, so what actually happens is that the silver, it will react with the sulfur in the air. Airle sulfur nate react cheyidittu it gets converted into silver sulfide. Okay, endayittu convert am, it gets converted into silver sulfide, which is black in color. Adana ee silver utensils inde molile you can see a black colored coating. Okay, black colored coating varuna adana. Yes. Ag2S ആണ് silver sulfide, which is black in color. Okay, it is black in color. Okay, this is corrosion of silver. Black color of, and not just silverwares. If you're using some silver jewelries and all, you can find some black color coatings on the jewelry items as well. Okay, it is reacting with sulfur in the atmosphere. Okay, airless sulfur react it is getting converted into silver sulfide. Okay, which is black in color. Yes, you can note this down. And then the next one is corrosion of copper. Yes, Abhi is like, ma'am, what about copper? You have seen this in horror movies. Okay, alright. Now, corrosion of copper, which we have already discussed. We first chapter already padichadana, corrosion of silver and copper. The best example is Statue of Liberty. Yes, Aditya, I'll explain it again. Don't worry. Yes. The best example was Statue of Liberty. Statue of Liberty was made up of copper. Copper color and it is some reddish brown color. Yes, reddish brown color metal. But you can see it is green in color now. Alle? Yes, now the Statue of Liberty is green in color. That is because the copper, it will slowly react with oxygen, carbon dioxide and water vapor, and it gets converted into basic copper carbonate. Basic copper carbonate, which has got a formula. I'll write it here. Okay, it will get converted into basic copper carbonate. Basic copper carbonate is represented as like this. C. Oh, just a second. Yeah. Cu. Yes, this is basic copper carbonate. It gets converted into basic copper carbonate. This is the reaction happening. So, is it clear? That's corrosion of copper. It gets converted into basic copper carbonate. Is it clear? Okay, yes. Now, just a second. Okay, yes. So, I'll explain this again, silver sulfide. Now, yeah, the silver utensils, okay, the silver utensils get oxidized. Okay, ma'am, can you please check that, this comment? Yeah, the silver utensils, it will get tarnished or it gets black in color. Okay, it gets black in color. Why? Because it will react with air in the atmosphere. Okay, it gets mixed with the sulfur. Okay, it reacts with sulfur and it will form silver sulfide. Okay, silver sulfide form G. This silver sulfide is black in color. Okay, the silver sulfide is black in color. Okay. Now, that is the reason for tarnishing of the silver. And the color of basic copper carbonate is green. Okay, basic copper carbonate is green in color. Okay, it is green in color. All right. Yes. Now, how will you prevent the rusting of iron? Iron rusting prevent. Okay, how will you prevent it from rusting? We have lot of techniques. We have painting, okay, or we can oil it, or we can apply grease to it. Then we have the most important one, that is galvanization. Okay, galvanization. Then we have chrome plating. Chrome plating no mean we are electroplating it with chromium. Chromium layer which it nammaladine coat cheyan. Okay. Then we have anodizing. Okay, anodizing and then making of alloys. Metals in the alloys and that is also an important method. Okay, that's also an important method. This prevention of corrosion is important. It is galvanizing and making of alloys. First, let's see. Yes, alloys. I have examples here. I have steel, I have bronze. Yes, perfect. Now, first one is galvanizing. What is galvanizing? Ever heard that before? What is galvanizing? It is the process of coating the iron article or the steel with a thin layer of zinc. Okay, a thin layer zinc vechittu coat cheyana nammada iron article ne. This process is galvanization. So in galvanization, what is used here? Zinc. Zinc vechitana nammal coat cheyyunnathu. Okay, is it clear? The steel or iron is protected from rusting by coating them with a thin layer of zinc. Okay, direct question, one more question they used to ask. Okay, is it clear? Yes, that is galvanizing. The next one is alloying. Okay, alloying endana padikkunennu munne what is an alloy ennu ariyana alle? Yes. What is an alloy? Alloy, you have studied this in your 9th standard. Okay, in the 2nd chapter, I guess. Yes, very good, Iona. Alloy is nothing but a homogeneous mixture. Okay, it is a homogeneous mixture of two or more metals or a metal and a non-metal. Randu koodal metals in your mixture or a homogeneous mixture of a metal and a non-metal. A homogeneous mixture, that is, the composition will be same throughout. Steel, iron, carbon. The composition will be uniform. That is a homogeneous mixture meaning. Okay. So what is an alloy? Alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. Or a metal and a non-metal. It is called what? This is called as an alloy. And let's see some common examples. First one, let me ask steel. Ever heard of steel? Steel is an alloy. Steel is an alloy of? Yeah, mostly we do galvanization for steel and iron. Okay, yes. Now steel is an alloy of iron and carbon. Iron in them, carbon in them alloy is steel. Now, what about stainless steel? Stainless steel is an alloy. It is a mixture of iron, nickel and chromium. Okay. What is the importance of stainless steel? It will not rust. You might have seen this in your kitchen. Okay. Kitchen landau. Yeah. Zinc. You don't have to study that in detail. The zinc, it will get, instead of iron, zinc reactive. Okay. During the galvanization. And zinc gets converted into basic zinc carbonate. Okay, yes, Abhinand. Okay. Yes, stainless steel is a mixture of iron, nickel and chromium. Okay, now what about brass? What about, yes, galvanization we use zinc, but we can coat with other metals like chromium, tin, okay, which electroplate. Yes, that is also possible. Yes. Now we have brass, which is an alloy of copper and zinc. Brass it's an alloy of copper and zinc. Now what about bronze? Bronze is an alloy of copper and tin. Bronze is an alloy of copper and tin. Now what about solder? Solder is an alloy of lead and tin. Lead in them, tin in them alloy solder. And in the alloy, if one of the metal is mercury, ഒരു metal mercury ആണ്, ബാക്കിയുള്ളത് ഏത് വേണമെങ്കിലും ആവാം. Okay, if one of the metal is mercury, then it is called as amalgam. Then it is called as amalgam. Is it clear? Yes, you can take a quick screenshot. Okay, yes. What is stainless steel? It is nothing but a mixture of iron, nickel and chromium. Brass is nothing but a mixture of copper and zinc. Bronze, it's a mixture of copper and tin. What about solder, lead and tin? And amalgam, mercury plus any other substance. One metal mercury aanu engil, that alloy is known as amalgam. Steel is an alloy of iron and carbon. Steel is an alloy of iron and carbon. Yes. Is it clear? Yes. Now the process of making this alloy is known as alloying. Okay. Some examples. First one is nothing but stainless steel. Okay. First one stainless steel. The second one is brass, which is an alloy of copper and zinc. Okay. Now the third one is bronze, which is copper and tin. Okay. These are some examples. Yes. Now, the process of making an alloy is known as alloying. Okay. Alloy indakkunna ee process neയാണ് നമ്മൾ എന്ത് ചെയ്യുന്നത് alloying എന്ന് പറയുന്നത്. Okay. Now, alloying is actually a very useful process. അതായത് നമുക്ക് നമുക്ക് വേണ്ട desired properties ഒക്കെ നമുക്ക് alloying വഴി നമുക്ക് കിട്ടും. Okay. Now, how will we prepare this alloy? First, നമ്മുടെ primary metal ഉണ്ടല്ലോ, that metal is melted. ആദ്യം നമ്മൾ നമ്മുടെ പ്രൈമറി മെറ്റലിനെ നല്ലപോലെ വീൽ മെൽറ്റഡ്. എന്നിട്ട് നമ്മുടെ ബാക്കിയുള്ള എലമെന്റ്സിനെ ഒരു ഫിക്സഡ് റേഷ്യോ ഉണ്ടാവും. ഇത്ര കോപ്പർ ഉണ്ടെങ്കിൽ ഇത്ര സിങ്ക്, അങ്ങനെ ഒരു ഫിക്സഡ് റേഷ്യോ ഉണ്ടാവും. ആ ഫിക്സഡ് റേഷ്യോയിൽ വീൽ ആഡ് ദി സെക്കൻഡ് മെറ്റൽ ഇൻ ടു ദി ഓർ ദി സെക്കൻഡ് എലമെന്റ് ഇൻ ടു ദി മോൾട്ടൺ മിക്സ്ചർ. എന്നിട്ട് നമ്മൾ റൂം ടെമ്പറേച്ചറിൽ വി വിൽ കൂൾ ഇറ്റ്. Okay, we'll cool it in the room temperature. That is how we prepare alloys. Is it clear? It is prepared by first melting the primary metal and then dissolving the other elements in definite proportions. There will be a fixed ratio. A fixed ratio നമ്മൾ mix ചെയ്യുന്നു. Then finally we are cooling it into room temperature. We are cooling it into the room temperature. Is it clear? This is called alloying. Okay. Yes. Now, alloying is a very good technique to get the desired properties. But there is a slight problem. Problem is the electrical conductivity. Okay. These alloys in the electrical conductivity and melting point, it will always be less than that of pure metal. Okay. Pure metal koravaayirikkum. For example, brass and bronze. Okay, brass, bronze, they are all alloys of copper. They are not actually good conductors of electricity, but copper is. Copper is a good conductor of electricity. Now, what about solder, which is an alloy of lead and tin? But solder and one alloy ki, they have got very low melting point. Okay, so you have to remember that the electrical conductivity and melting point of an alloy is less than that of what? Pure metals. Okay, you can note this point. Is it clear? Okay. Yes. Now, the last topic. Okay, pure gold. Okay, pure gold is 24 karat, that we all know. Yes, I'll show you the slide, don't worry. Don't worry, okay. Pure gold is nothing but 24 karat gold, but it is actually very soft. Pure gold nu parayunnathu it is soft. Appo namukku ornaments okke undakumbo our resistance okke koravayirikkum because it's not that hard. So it is not like pure gold orikkalum nammal jewelry undakkan ubhayogikkilla. Okay, it is often alloyed with either silver or copper. Silver ne copper ne aayittu ഒരു alloy form ചെയ്തിട്ട് ആ alloy ആണ് നമ്മൾ യൂസ് ചെയ്യുന്നത് എന്തിന് jewelry ഉണ്ടാക്കാൻ. And we mainly use 22 karat gold for using for making ornaments. That means 22 parts gold ആയിരിക്കും. Okay, 22 parts will be gold And the rest 2 part will be either silver or copper. Rest 2 part will be either silver or copper. Okay, is it clear? Okay, yes. So any doubts so far? ഇതുവരെ നമ്മൾ പറഞ്ഞതിൽ എന്തെങ്കിലും doubts ഉണ്ടോ? Or do you find any topics difficult? Should we quickly revise it? എന്തെങ്കിലും difficulty തോന്നിയോ? Do you have any doubt? Other than slides അല്ലാതെ, do you have any doubts? No doubts in particular? I can see some carrot emojis. Okay. Alright. So we were discussing about what? We were discussing about extraction of metals with medium reactivity. Okay. Medium reactivity. Anodizing we already kandadalle. Then we have already discussed anodizing in our previous classes. Okay. Yes. Yes. Medium reactive metals. They are all present as either as their sulfide or as their carbonates. Sulfides item, carbonates item and our first we'll convert them into their oxides, and from that we'll reduce, we'll undergo it, we'll conduct reduction. No, you will not have chapter test today. Okay, and from that the metal is extracted. Okay, yes, the part with calcination and roasting. Yes, now sulfide ores, what we are going to do is sulfide ore is treated or it is heated in presence of excess air. Excess air we heat sulfide ores. The sulfide ores gets converted into its oxide. We call it as roasting. Okay, roasting. In roasting, there will be presence of excess air. But calcination, there is only limited supply of air. You can see absence of air. Okay, absence of air, it gets converted into its oxide, or limited supply of air, it gets converted into its oxide. That is calcination. Roasting is mainly done for sulfide ores, and calcination is mainly done for carbonate ore. Okay, അങ്ങനെ നമുക്ക് എന്ത് കിട്ടിയ മെറ്റൽസിന്റെ oxide കിട്ടി. Now ഈ oxide ൽ നിന്ന് we use a suitable reducing agent to reduce the metal. Okay, metal ne reduce ചെയ്ത് കിട്ടാൻ വേണ്ടിയിട്ട് we use a reducing agent, and the common reducing agent that we use is nothing but carbon. Okay, carbon. In carbon മാത്രമല്ല, we can use what? We can use highly reactive metals. Okay, highly reactive metals vary displacement reaction നമുക്ക് നടത്താം. So these metal act as the reducing agent. അപ്പോൾ ഈ reaction എന്താണെന്നാ പറഞ്ഞത്? This reaction is highly exothermic. It is so exothermic that the metal obtained here, okay, the metal which is obtained here is in it is obtained in molten form, liquid formula ആണ് നമുക്ക് കിട്ടുന്നത്. Okay, and we saw thermit reaction, which is the reaction between ferric oxide and aluminium. Okay, yes, which is used to join the railway tracks and also the cracked machine parts. All right, yes. Then what? Then we saw what like the extraction of metals with high reactivity. Highly reactive metals in എങ്ങനെയാ നമ്മൾ extract ചെയ്യുന്നത്? We'll conduct electrolysis. എങ്ങനെയാ electrolysis നടത്തുക? We'll take the molten chloride. Molten chloride എടുക്കും. We'll pass electricity through it. അപ്പോൾ എന്ത് ചെയ്യും? The metals will get deposited at the cathode, and chlorine gas will be liberated at the anode. Okay, metal എവിടെയാണോ കിട്ടുന്നത്? കാഥോഡിൽ കിട്ടും. ആനോഡിൽ we get chlorine gas. Alright, yes, this is the reaction that is happening at cathode and anode. Always remember, cathode reduction takes place. Okay, reduction takes place at cathode, and at anode it is oxidation that is taking place. Alright, yes. Then what? Then we discussed about refining of metals. Refining of metals nu vecha enda? The metals so obtained will definitely contain lot of impurities. Okay, aa impurities nokke we should remove it. Okay, അതിനെയാണ് നമ്മൾ refining of metals ചെയ്യുന്നത്. Okay, and the most common method that we use is electrolytic refining. Okay, now electrolytic refining is very important. Anode, always remember, impure metal. Impure metal ആണ് ആനോഡിൽ ഉണ്ടാവുക. Both anode and cathode will be of same metal. Same metal ആയിരിക്കും. അതിൽ impure ആയിട്ടുള്ള metal ആയിരിക്കും ആനോഡിൽ ഉണ്ടാവുക. കാഥോഡിൽ pure metal ആയിരിക്കും ഉണ്ടാവുക. ഏത് metal ആണോ വേണ്ടത് അതിന്റെ തന്നെ salt solution ആയിരിക്കും my electrolyte. And on passing electricity, what happens? You can see that the anode will become thinner and thinner and cathode will become thicker and thicker. Cathode ilana pure metal vannittu deposit cheyyunnathu, and as a result it becomes thicker and thicker. And the insoluble impurities will fall below the anode. Anode inde thaazhe settle cheyyum and it is called anode mud. Okay, it is called as anode mud. Then what? Then we discussed about corrosion. Okay, corrosion endanu padichu. Then we saw rusting of iron. Okay, we saw rusting of iron. Then what? Rusting of iron. Then tarnishing of silver, corrosion of copper. Then the ways how can you prevent corrosion? ഇതാണ് നമ്മൾ ഇത്രയും ചാപ്റ്ററിൽ കണ്ടത്. Okay. So if you have, like, if you don't have any doubt, shall we conduct the exam then? Shall we? Yes or no? Okay, yes, I think you're ready to write the exam. Yes, sir. So it's time to say goodbye to our YouTube family as well. So a huge bye from my side. See you in the next class, guys. Thank you so much. Guys, you don't leave. Okay, we have exams now. You can quickly revise and go through what we have learned. Yes.